Hello, my name is Shawn Hawkins. I'm an associate professor in the Biosystems Engineering and Soil Science Department. That's in the University of Tennessee Institute for Agriculture. Today I'm going to be speaking with you about the past 3 years of research that we've been conducting concerning corn silage agronomics, nitrogen agronomics specifically, and also mineral nutrient removal rates. So I'm going to go ahead and pull up the presentation for today. And I'm also going to go ahead and take away my video feed so that you'll have the full benefit of the screen for the graphs and also the tables that I'm going to be showing shortly. So the title of today's presentation is Corn Silage Nitrogen Agronomics and Mineral Nutrient Removal Rates. This is part of the proceedings for the 2020 Mile and No-Till Virtual Field Day. I'd like to begin by thanking Hannah McClellan and Wesley Wright. They're co-authors for today's presentation and provided invaluable assistance in conducting this research. I'd also like to thank the Tennessee Department of Agriculture. They provided the funding for us to conduct this research. The goals are to review the nitrogen response of corn silage in terms of the yield and the silage quality, and also to cover mineral crop concentrations and harvest removal rates, which are very important for corn silage because we do remove the entire plant. The concentrations of certain macro mineral nutrients such as phosphorus and especially potassium are very high. And of course, that's realized as a cost for production. We'll also go over some of the characteristics that we see in micronutrient concentrations as nitrogen concentrations, fertilization rates vary. To begin with, I'd like to present the current UT Extension corn recommendations and nitrogen recommendations for corn in our state. They're divided into two different categories. One is for grain production and the other silage production. And you'll see that our concentrations, and like many crops that we produce in Tennessee, the concentrations of nitrogen in this case vary depending on the anticipated yield for the field, for anywhere between 120 and 240 pounds of nitrogen per acre. So for example, if you're expecting a yield between 150 and 175 bushels an acre, we recommend an application rate of 180 pounds of nitrogen. And if you're in irrigated fields or in high producing fields, perhaps in West Tennessee, and you're producing more than 200 bushels an acre, then our recommendation would be for 240 pounds of nitrogen per acre. So the nitrogen, if we were to normalize that or divide the amount of nitrogen that we're recommending by the number of bushels that we're anticipating to produce, you can see that the N rate is a little more than 1 pound of nitrogen per bushel produced. And this is typical for land-grant university recommendations. And of course, that is verified with many years of research across many different land-grant institutions. These are our current silage recommendations. Again, we have different tiers of nitrogen application rate recommendations, but there's only 3 in this case: 120, 150, and 180 pounds of nitrogen, corresponding to 15 to 18, 19 to 25, and then above 25 tons per acre. If we were to convert these tonnages to bushel equivalents and then examine the amount of nitrogen that we're recommending normalized to the bushel equivalents, you can see that in this case, some of our recommendations are slightly below 1, and that's part of the reason to conduct this study, to see whether or not we can justify increasing the nitrogen application rate recommendations for our new corn silage varieties, some of which will certainly in good years yield well more than 25 tons an acre. This is the study design. We had 7 treatments, a negative control, which did not receive any nitrogen fertilizer, but which was fertilized for phosphorus and potassium. So nitrogen is the only limiting nutrient in this study. The remaining treatments received 80 pounds of nitrogen at planting, and then a variable rate of nitrogen at the split application, in which case this was V6, and that's common for producers in the state to split nitrogen applications. that range from 40 to 70 to 100 to 130, 160, and 220 pounds of nitrogen. The 5 of these represent the current tiers of nitrogen recommendations per corn grain. That would be 120, 150, 180, 210, and 240 pounds of nitrogen. The final rate is an excessive rate, one that we would consider uneconomical, and we anticipated, in fact, that that would depress yields. All of the studies throughout the 3 years that we've been, all of the plots throughout the 3 years that we've been conducting the study were conducted with Pioneer 2088 in a poll of dairymen in the state. That's the most common corn silage variety planted. And then for each of these treatments, we replicated those 4 times, and we replicated the entire plot array at 4 different locations, near Knoxville and Crossville, Springfield, Tennessee, and Spring Hill, Tennessee, at our different research and education centers. All of this to say that the study is well replicated. Rather than present to you the yield for each year, for each station, what I've done is I have created a global average of all of the results that we've obtained in terms of yield. The yield is quantified on this axis here in tons of silage per acre at 65% moisture. And you can see that the global average ranges from 22.2 up to 25.2 tons per acre at 120 and 240 pounds of nitrogen per acre. I have our tiers, our current tiers of nitrogen recommendations. 15 to 18 is 120, 19 to 25 is 150, and then 25 and above is 180. So this would be normally what we would recommend for these yields. The way we're evaluating whether or not there is a significant yield response is we have fit this average, and obviously there's a lot of variability. These lines drawn from the circle up and down represent the variability. We fit these points with a line, and we have evaluated whether or not the slope of that line is different than 0. Obviously, if the slope of the line can be 0, it's an indication that there's no response in terms of yield, or not a significant response based on the data that we've collected as the nitrogen application rate increases. So the slope, once we've done the statistical analysis, did in fact include 0. The range was -0.1 to 1.6 tons per acre. That's for each 30-pound increase in the nitrogen application rate. So this range tells us a couple of things. Number one, based on the amount of data that we've collected so far, we can't say that the slope is statistically different than 0. However, there's a good indication, the vast majority of the range of the slope indicates that there is an increase in corn silage yield as the nitrogen application rate is increasing. And it appears that if we were to replicate this enough, that it would be on the order of 1/2 a ton to perhaps 3/4 of a ton per acre for each 30-pound increase in the nitrogen application rate. Now, another way to look at this is in terms of silage quality. And in this case here, what I've done is I've took the crude protein concentration, which did increase significantly as the nitrogen application rate increases, and I've quantified it in terms of the yield in pounds of crude protein per acre. And you can see that in this case, I've got all of my averages lined up here. And when I fit these averages with a straight line, the slope of that line is significantly different than 0. It's at least 30 pounds of crude protein per acre of an increase for every 30-pound increase in the nitrogen application rate. And it could be as high as 130 pounds. So there is some improvement in corn silage quality. The take-home messages. There's little, if any, yield increase above 180 pounds of nitrogen per acre. In any given year, it appears that you would have about 1/3 of a chance of not improving yield at all. Perhaps in 1/2 or 2/3, you might get a modest increase in yield that may or may not be justified with increasing the nitrogen application rate above 180 pounds. There is a slight crude protein yield increase, and we're currently evaluating that to see if we can justify adding at least another tier of nitrogen recommendations. But we'll only do that if it's if it's economical. Should you apply high N rates for high yielding fields? I don't believe so. I think our current recommendation of 180 pounds of nitrogen per acre is still a good maximum rate. It's economical with low risk. And if you do have an increase in yield, that increase is going to be on the order of, somewhere around a half a ton. If you consider that the silage is worth perhaps $30 a ton, that would be an improvement in value of $15 an acre. So obviously we're going to have to spend some money on nitrogen to increase that yield. And if nitrogen's at 50 cents a unit and we need another 30 units to improve our yield a half a ton, that's basically a break-even proposition. It's going to cost us $15 in nitrogen to produce $15 in terms of the increased corn silage yield. Now, moving on to the second half of the presentation, we're going to focus on mineral concentrations and removal rates, particularly of phosphorus and potassium. And I should begin by mentioning that we have a brand new publication that covers this data in more detail. If you'll Google corn silage mineral and nutrient removal rates, you'll be able to pull this up. I would encourage you to do that at your leisure, and you can review in more detail the data that we're going to present here. There is a one-page producer summary if you want to review the summary, but not the details of the data. But there's more detail overall in this publication than I'll be presenting today. I'm going to begin by presenting basically all of the data that we've collected through all of the years of the study thus far, 2017, 18, and 19, at all of the different locations, M-Track at Spring Hill, Tennessee, the Plateau Station at Crossville, Highland Rim, Springfield, Tennessee, E-Track at Nashville, Knoxville. So in all of the cases here, what I've plotted is the concentration of phosphorus in the silage, and that's across all of the different nitrogen fertilization rates that we used. The box represents the center 50% of the data that we've collected, and you can see that I'm referencing these boxes to different values that are purported to be the concentration of phosphorus in silage. One of these in particular is very important. The solid red line is 3.6 pounds of P2O5 per ton of silage, and that represents the value in the manure management planner, which many dairy producers and some beef feedlot producers use to try to match manure phosphorus concentrations with crop removal rates. Clearly, if we look at the overall average across all of the stations and all of the years of the study, this line here is the median value, and you can see that 50% of the data is above this line and 50% of the data is below this line. This median value is up around 4.2 pounds of P2O5 per ton of silage. That's well above the concentration that's currently used in MMP. And I would also mention that the concentration that we see in Tennessee is above the concentration that's referenced in the USDA crops database. So going on and looking at the average for all of the stations for each year, a global average is 4.2 pounds of P2O5 per ton of silage at 65% moisture. That's a pretty good estimate of what the corn silage concentration is going to be. But again, flipping back to this graph, the emphasis here is on the variability. There's a tremendous amount of variability through time. And also at the same station, there's variability in some years, even at the same locations and within the same fields in terms of the silage phosphorus concentration. Moving on to the phosphorus removed, this is an important point. So basically here we've taken the phosphorus concentration and multiplied it by the yield. And you can see that in most cases, if you're considering perhaps 180 pounds of nitrogen per acre, the yields are going to correspond to a removal of somewhere between 75 to 100 pounds of P2O5 per acre to 125 to 150 pounds of P2O5 per acre. Moving on to the potassium concentration, I'm not going to show the detailed graph here, but clearly you can see from the averages that we have here for the different experiment stations in different years, we have averages that vary quite a bit. The lowest being 7.6 pounds of K2O per ton of silage harvested. And the highest one here is up over 12 pounds of K2O per ton. The average being 9.8 pounds of K2O per ton at 65% moisture. Again, looking at the concentration multiplied by the yield, and assuming that we're fertilizing with 180 pounds of nitrogen per acre, you can see that the potassium removal rates are very high, between 200 and 300 pounds of nitrogen per acre. The take-home message: with these high removal rates, if you have organic fertilizers like dairy waste or feedlot manure, or perhaps access to litter or compost, you need to be targeting those organic fertilizers to corn silage fields, because the potassium removal rates in particular are almost cost prohibitive in terms of replacing the potassium that you're removing with the corn silage. So you need to find sources of mineral nutrients that are more economical than commercial fertilizers. You should be aware, and I hope I've shown, that the P and K concentrations and the removal rates are highly variable. They vary from farm to farm. If you're renting different farms, even within the same farm, they're going to vary from field to field. Even within the same field, they're going to vary from year to year. And you can anticipate there'll be some variation across nitrogen application rates. For this reason, another take-home message is that if you're producing corn silage, you need to be soil testing, in my opinion, yearly, and at a minimum every 2 years, because of the high removal rates. You don't want to get in a situation where your phosphorus and potassium are limiting yield. It would be very expensive to take a field from a yield limiting soil concentration to an unlimited concentration in any given year. So you need to stay on top of your soil testing. If you don't have estimates of your mineral nutrient removal rates, it appears that the P2O5 is going to be somewhere between 75 to 100 pounds of P2O5 per acre, up to 150. If you have your yields, you can multiply our average concentration by your yield. Again, your yield needs to be normalized to 65% moisture, and you would be able to obtain an estimate of your phosphorus removal rates. And the same goes for potassium, which typically will be 200 to 300 pounds of K2O per acre. And this concentration can be multiplied by your yield at 65% moisture to estimate your crop removal rates. One last thing I want to cover is that a phenomenon that we have seen with some mineral nutrient concentrations, and I've kind of alluded to that in a couple of the slides previously, and that is that they can increase with the nitrogen application rate. I'm going to show here the sulfur removal rates. So I've taken the sulfur concentrations of our corn silage, which tends to increase as the nitrogen application rate increases. So I have the sulfur removed here in pounds of sulfur per acre, and you can see that as the nitrogen application rate increases, the removal rate for sulfur increases significantly. Any bar here that's shown with a letter that's not in common with another bar, basically that means they're statistically different. So for example, at 180 pounds of nitrogen, the sulfur removal rates are higher than we would anticipate at 120 or 150. This is important because long-term over-application of nitrogen, in other words, application which cannot be justified with a yield increase, can lead to mineral nutrient deficiencies, and eventually we would expect that to increase production costs, because at a point where minerals are limiting yield, you're going to have to replace those in your fertilizer mix. If we look at the minerals where we see the more pronounced increases in concentration as the nitrogen application rates increase, those are sulfur, copper, and zinc. Again, prioritize manure or other organic fertilizers to corn silage because it provides a broad range of macro and micronutrients, not just potassium and phosphorus, sulfur, copper, and zinc, but also elements like boron and manganese. Thank you. I appreciate the opportunity to be able to present you this research. Again, I want to thank the Tennessee Department of Agriculture for providing the funding to conduct this research, and Hannah McClellan and Wesley Wright for their invaluable assistance in collecting this data. It's very laborsome to collect the data that we've presented today. If you have any questions with anything you've seen, please don't hesitate to give me a call or send me an email. My email is just shawkins@utk.edu, or if you prefer, you're certainly welcome to call my cell phone. That number is 865-207-7156. Again, thank you.